Hi, welcome to Predicting the Real World Phenomena by Tim Scott for the University of Houston. This presentation is going to familiarize students with the use of computation models as tools to describe and predict real-world phenomena. The first technology that we're going to look at is handheld GPS. Handheld GPS recorders are used to mark the terrain and unique locations around the world. They record their position, their altitude, and all other associated data can be recorded into one specific unit. Most people are familiar with GPS units as being in their phone and for helping them get from point A to point B in a car. But in the field, they're used to record positions around the world. Currently, a lot of GPS units are being used in Greenland to track the amount of ice that's left on Greenland as it's melting during the summer. The next we're going to look at is Denali, or otherwise known as Mount McKinley. Mount McKinley is a mountain north of Anchorage, Alaska, in Denali National Park. Denali has always been recorded as being 20,320 feet. But in the last couple of years, they've remapped the mountain using radar mapping, which allows it to penetrate the ice at the top of the mountain. After they did that, they realized that the mountain is actually shrunk 83 feet because of the ice. It is now listed officially at 20,237 feet. This is a portable seismograph. Seismographs are used to measure the amount of movement that the earth makes during an earthquake. These seismograph readings can give us a lot of information, and they can help us predict where other earthquakes are going to occur. This is a little drawing that shows how a seismograph actually works. You have on the ball hanging down, you got a weighted ball with a pen at the bottom. The paper at the bottom moves through, and as it moves through, if the earth is shaking, it records the amount of shaking that occurs. This is a picture of the earth for one day. This is April 16th of 2013. There was a lot of seismic activity within one 24-hour period along the western edge of the Pacific Ocean. This was just one day and a much larger swarm of earthquakes that were occurring within a 7-day period. This is a 7-day period of earthquakes of 5.0 or greater in magnitude from April 12th to April 19th of 2013. While we cannot actually predict when an earthquake is going to occur, we can predict if a tsunami is going to happen as a part of that earthquake. This is a picture of the tsunami that hit Japan after the Japanese earthquake several years ago. Another thing that earthquake readings can give us is to help us maybe predict a little bit that a volcano is going to erupt. This is Mount St. Helens on May 18th, 1980. Unique thing about Mount St. Helens is that it had been dormant for over 130 years. Its last known seismic activity had occurred in 1850. Then on March 15th of 1980, earthquakes started occurring on the mountain. Within 2 months, it had erupted. It killed 57 people, caused over $2 billion in today's dollars of damage. This is the preliminary determination of epicenters of all seismic activities between 1963 and 1998. This is how scientists arrived at the description of plate tectonics. Each plate, as you can see through the mapping of the epicenters, gives us a rough idea of where each boundary is. It allows us to predict where future phenomena is going to occur. Thank you very much. Have an excellent day.